Welcome. Before we begin looking at graphing logarithmic functions with transformations, I thought we would do one exponential, and it was one exponential we missed in the notes. So find this one in your notes, and that's the end behavior of the graph f of x equals 4 minus 3 to the negative x as x goes to infinity and negative infinity. So we're looking for the end behavior here. All right, so first of all, we should rewrite it because it has a negative exponent. All right, so this would be, whoops, got a strange box here. F of x equals 4 minus 1/3 to the x, right? By the way, we could have also written that, the ordering that we add things doesn't matter. So we could also write that as f of x equals negative 1/3 to the x plus 4. All right, so this is decay. And with the basic shape of the decay, it's going to go like that, right? It's going to have a shape like that. This particular graph, because we have a plus 4, right? This particular graph has been translated up 4, right? So our base graph, I'll just sketch just a very basic base graph here, right? So it's going to go through the point, except it's going to be on the negative side. It's going to go through the point -1, 0, because that's actually, we'll get some points for our base graph because it's been reflected. It's that negative there. All right, so if I were to plug in 0, I'd have negative 1/3 to the 0 power, and that would be a negative 1. All right, if I plugged in -1, I'd have negative 1/3 to the negative 1 power, and that's going to flip it. It'll still be negative, but now it'll be -3. All right, so for -1 there, we're going to be at, let's draw a little graph there. Whoops, forgot to count my point. There we go. All right, so this one was 0, 1, or 0, -1, excuse me. And then this one was -1, -3. And then if we plugged in one more point, we would, if we were really graphing this, we'd plug in more. But we're just going to graph. We're just basic little sketch so that you can figure out the answer to this question. All right, so for +1, that would be a negative 1/3. Right, so this would be the base graph. Right, and then, of course, it's not going to cross the asymptote. But this particular function has been shifted up 4. All right, so all those points are going to move up 4. 1, 2, 3, 4 right there. Right, and we'd have a horizontal asymptote right there at y equals 4. And this one, that negative 1/3 is now going to be right there, a third below that line. And then this one I can count. 1, 2, 3, 4 right here. All right, so here is our graph of our function there. And let's write the end behavior. Right, so what happens as x approaches negative infinity? So f of x is going to, as x approaches negative infinity, I'm writing another color. As x approaches negative infinity, notice that the graph will be getting smaller, right? It's as we're going this direction, the graph is going this direction. So f of x approaches negative infinity as x approaches negative infinity, right? And our functions are always going to head to the asymptote at some point, right? If it's decay, right, decay is going to head to the asymptote as f of x approaches positive infinity, right? And we went through that. Right? So, oops, it's not going to approach infinity, it's going to approach the asymptote. Right? So our function is going to approach the asymptote as x approaches infinity. So our function is going to approach 4. All right, so if your growth, all we got to really do in this problem here is figure out growth or decay. All right, so if it was growth, right, it's going to move away from the asymptote as x approaches infinity and towards the asymptote as x approaches negative infinity. If it's decay, right, then it's going to be the reverse. It's going to move towards the asymptote as x gets larger, right, because 1/3 to a smaller and smaller power gets, to a larger and larger power gets smaller and smaller and smaller. And it's going to approach, in this case, negative infinity because it's reflected as x approaches negative infinity. So really all you got to do first of all is figure out growth or decay. So on these problems, when you're looking at end behavior, figure out growth or decay. Right? Decay, for growth, the function moves towards the asymptote as x approaches infinity. For decay, it's going to move towards the horizontal asymptote. Oh, excuse me. As x approaches negative infinity. I had decay on my head. So growth, your function approaches the horizontal asymptote as x approaches negative infinity, right? It's going to move away from the asymptote as x approaches infinity. And we can put that in there. And away from horizontal asymptote as x approaches infinity. And then the reverse is going to be true for decay. Your function is going to move towards the horizontal asymptote as x approaches infinity and away from the horizontal asymptote as x approaches negative infinity. So it's just going to be reversed. Right? And then the other thing to look at is it reflected? Right? So if a, right, which is your coefficient or starting value, and it doesn't matter whether this is growth or decay, but if that is negative, right, then it's going to be negative infinity instead of infinity. And it doesn't matter which way, whether it's growth or decay. All right, so just a little review there on your exponential functions. And now let's look at logarithmic functions. I'm going to start a new podcast, and we'll begin logarithmic functions. Thanks for watching this one. Bye for now.